if I tell you something like all the girls in the class eat chocolates. Now, if this statement is true, how would you prove it? If the statement is true, if all the girls eat chocolates in the class, how do you prove that? Well, it would be your job, what? To prove that all girls, right? Let's put that in red. Let's underline that in red. That all girls in the class eat chocolates. It would be your duty. Ooh, chocolates, that doesn't make sense. It's chocolates, right? If it is true, it would be your duty to prove that every single girl in the class eats chocolates. Just think about that. Why is that particularly the case? Because I made the statement that all the girls eat chocolates. So you need to show me somehow or the other that every single girl eats chocolates in the class. Well, I would suggest giving each one a piece and then seeing if they eat it. If they eat it, everybody eats it. Anyway, I digress. If the statement was false, if it was false, what do you need to do? Well, because I claimed that all the girls in the class eat chocolates, my statement is that every single person in this class eats chocolates. What are you going to do? You're going to say, well, Imad, Malika doesn't eat chocolates. So, that's all you need to do. You just need to show me. If it's false, you need to prove that at least one person doesn't eat chocolates. Okay, so if I say all and I say every single girl in the class eats chocolates, and if the statement was true, how do we prove that? We need to show that for every single girl eats chocolates. If the statement is false, then we must show that at least one person doesn't eat chocolates. So I'm going to go back to this thing over here. I said it's x cubed, right? X cubed multiplied by y squared is equal to x to the 5 multiplied by y squared. Now, let's write it out again. It's x cubed y squared is equal to x to the 5 y squared. Now, in mathematics, x and y are considered general, right? We would consider these variables that can take on any number. Now, when I say any number, it means whatever number I put in there, the statement must hold true. So how do we check that? Is there a way? Well, let's see. Choose any arbitrary x. Let's make x equal to 2, and let's make y equal to 3. Okay. Now, let's take the left-hand side, and let's take the right-hand side independently on this side. For the left-hand side, let's substitute. Let's say that x has a value of 2. It's going to be 2 to the power of 3 multiplied by y, which in this case is equal to 3 to the power of 2. And 2 to the power of 3 is equal to 8 because it's 2 times 2 times 2 multiplied by 3 squared, which is 9. And 9 times 8 is just going to be 72. Right. What about the right-hand side? The right-hand side, again, if I put in 2 in x, substitute the value 2 there, 2 to the power of 5 multiplied by 3 to the power of 2. Well, 2 to the power of 5 is actually 32 multiplied by 9. And 9 times 32, if my memory serves me correctly, it's going to be 320 minus 32. It's going to be 320 minus 32, and that should be 12. It's going to give me 288. So the right-hand side gives me 288. So is the statement true? No. The statement is false. Why? Because when I chose x equal 2 and y equal 3, it failed. It was false because I showed there's at least one x and y where things don't work. Now, if it was true, Well, I need to use the laws and I need to be able to prove it in general. Right now, we are not focusing on proving things in general because we need maybe induction or something to show that it works for every single x. But right now, I know it's false, so I'm just going to find one x and y where this doesn't work. I'm going to show you a case where it's possibly true, where this case is only true if x equals 1. Or if x or y equals 0. And you can think about why that is the case, right? Please do think about only true if x equals 1, but that is not general. And therefore, statement is false. Okay. Let's go on to the next one. Let's see. X to the power of 2 plus x to the power of 3 is equal to x to the power of 5. True or false? Well, what do you say? It is false. That's good. Now, why is it false, guys? Let's think about it. Because you can only add exponents if you're multiplying things with the same base. That there is addition. Because it's addition, we cannot add the exponents. Okay, let's look at this again. Because it's addition, I cannot add the exponents. In terms of the laws say if you have two things with the same base and different exponents, I can add the exponents. But that's only if I'm multiplying those two objects. In this particular case, I'm not multiplying them. I'm really just taking something and adding something else. So I have to look at the sum. Is it equal to this? Well, let's start with the left-hand side. What is the left-hand side? The left-hand side is x squared plus x cubed. And if I look particularly at that, I can say let's choose a value for x. Let x equal 2, just for our example, right? And we want to prove this false. We know it's false because the law doesn't say you can add the exponents if you're adding these variables with the same base. You must be multiplying them. So let's look at this. Let's say it's 2 to the power of 2 plus 2 to the power of 3. And what does that give me? 2 to the power of 2 is equal to 4, and 2 to the power of 3 is equal to 8, and 4 plus 8 is 12. And let's take the other side. What is the right-hand side? Well, the right-hand side is equal to the following. The right-hand side is equal to x to the power of 5. Now again, if we let x equals 2, then I would say that that is equal to 2 to the power of 5. And you've already seen that's 2 times 2 times 2 times 2 times 2. And that's going to give me 32. So clearly, we make a statement. We can now say that the left-hand side does not equal the right-hand side. Okay. Now I'm going to leave two more here for you to try. I want you to do this in your handbook. P plus Q squared is equal to P squared plus Q squared. And you need to let me know if this is true or whether this is false. And then finally, let's take another one. 5 to the power of negative n, and this is something you should know, is equal to negative 5 to the power of n. And I just want to caution you on something here. Negative 5 squared is equal to negative 25. But negative 5 squared here is equal to positive 25. Just think about that, right? Over here, we need to use BODMAS or BEDMAS. or PEMDAS as some may call it. And over here, well, you're simply just saying negative 5 multiplied by negative 5. And that over there is equal to a negative times a negative gives me a positive, and 5 times 5 gives me 25. Okay, whereas in this case, the thing that happens over here, what happens over here is I have to first take, that is 25, and then I go and I multiply it. So that's step 1, and then multiply by the negative. That's step 2. Using the laws here, it says brackets, there's no brackets. Something's wrong. Okay, there's no brackets, and we first have to take the exponent. 5 squared is 25, and then we got to say 25 positive multiplied by negative. And I want you to do that. If you've got a scientific calculator, type it in the way you see it here and type it in the way you see it there. Okay, and then remember, as part of the activity and the exercise right now, you need to tell me whether this is true or false, as well as whether this over here is true or false.